Hello everyone and welcome to this session. My name's Gareth Metcalf. I run a company called IC Maths and I'm really passionate about developing children, particularly in their early mathematical skills. We're going to really explore all of that today, lots of resources, lots of ideas, so I hope you're going to find that really useful. We're going to start by looking at the combination of children's ability to recognise quantities and subitize and see quantities in different arrangements, with also their understanding of counting and their understanding of quantity through counting, tying those skills together. So welcome everyone to this session all about early number sense. I hope to provide real coherence in terms of the challenges that children face with developing early number sense, why there are such challenges, how can we address them through children's counting experiences, the quantity recognition experiences, and then looking at deepening estimation and understanding of pattern. So again, I hope to provide really clear guidance on how those skills develop. What I want to start with is considering children's starting points and the challenges that provides for us. Now, lots of research has shown the enormous importance of children's earliest maths experiences. So this was a study that I came across a few years ago, which I found fascinating, from the Ericsson Institute of Early Maths Education. And they looked at the significance of children's early maths skills and then their later academic achievement. And what we found, you'll be surprised to learn, that early maths skill was very predictive of later maths achievement. In fact, much more so than early reading skill was of predicting later reading achievement. Early maths skill, though, was also seen as an enormously powerful predictor of overall academic achievement. And also, there was a stronger correlation between early maths skill and later reading achievement than between early reading skill and later reading achievement. Something that I've always found fascinating. Now, I think there's a case to be made in maths for, like, children come to school with very different starting points. And I think there's a case to be made as to that being because maths isn't something that's biologically primary. It's not something that we've only recently had to acquire in our human development. Whereas language is something that you could describe as being biologically primary. We've always needed to develop and acquire language, and our minds are kind of already wired for us to do that. Much like we learn to recognize how someone's emotion based on their facial expression. Whereas maths is a skill that we've had to acquire more recently. So we could describe that as being more biologically secondary. And I think that means that children's earlier experience of maths, the experiences they've had before they even start at school, mean that they will differ enormously. And so children's level of competence in maths differs enormously when they come to start school. And we know that where children have had aren't necessarily less able in maths, but maybe they've had less exposure, those children can develop negative attitudes towards maths, and it's common for that gap to ever widen in attainment. Now, I wanted to start off by thinking about, well, why is that, and what can we do to address that? And to do so, I want to give you a slightly different challenge to kick off. So this is obviously our number system, and I've got a few kind of calculations here that will be hidden. And what I'm going to do is I'm going to ask you to do, as I say, these few things. So I'm going to give you 2 addition calculations. I'm going to ask you to see if you can do a count sequence, and then I'm going to put some dots in and around that 10 frame. I'm just going to ask you how many. Now, the only little twist is we actually won't use our number system exactly as it's presented. So what I'm going to do is I'm going to change the symbols, what they look like. But you'll have enormous advantages when you do this to children, in that you will already recognize all those symbols and you'll even know them in order. But what I want you to do, I'm going to present a different number system, and I want you to do the calculations that's presented in this new number system. So don't do it in our number system and then convert back. As far as you can, do all the calculations in this new number system that you'll be given. And this is all about you empathizing, well, what's it like to do maths as a younger child? And what are the key skills that we need the key pieces we need to give children as they move forward in mathematics? So this is the number system that I want you to deal with. So A is 1 and B is 2 and so on. BO is 20. And I'm going to ask you in a moment to pause the video and have a go at some calculations involving this number system. And again, if you can describe everything that you do in this number system. That will be really helpful for the purpose of this activity. So here we go. The calculations I wanted you to have a go at were D plus C, G plus E. Now have a go at counting in steps of B to get to at least BO. Now see if you can do that eventually without looking at the grid. So you'll need to look at it first, but can you do that without looking at that grid? And then how many dots are there? And again, describe using this number system, how many dots there are and how you know. So pause the video, have a go, and we'll have a look in a moment at some reflections based on that. Okay, and I'm going to bring us back together. So hopefully you're ready to play the video now, and you've had a go at that. I wonder how you felt emotionally doing that, and how that impacted your experience, whether you wanted to talk and share ideas. But hopefully you also felt like almost emotionally what maths is like for younger children as well, potentially threatening even. Now let me talk through some of the calculations and why I chose them specifically. So let's say, first of all, D plus C. Now my guess is you probably used the grid and you started from D and you went A, B, C, and you stopped when you got to G. Now you have to make sure that you don't say D, E, F, because you don't say the D when you're doing D plus C. You have to start by saying the E, the next number in the count. Of course, if you didn't have that grid, what you'd need to do is you'd need to start from D and in your head, and you'd have to go E, F, G. And what you'd have to do is you'd have to track how many sounds did I make then? E, F, G. Oh, that was A, B, C sounds. I said C sounds then, so I did count on C. And they're all the skills children have to do to be able to do 4 add 3. I'll get back to breaking that down in a moment. So similarly, G plus E, I imagine you did G plus E by counting on. But let's say we want children eventually to learn more efficient strategies. Now, G plus E is the equivalent of G plus E is 7 add 5, which is what I told you not to do. It's 7 add 5. Now, how do we do 7 add 5? Well, maybe we do double 5 add 2. Or maybe we split the 5 down into a 3 and a 2. So we know that that's 12. So I guess the things I've just described are, I'd need to know that E plus E is AO, and so split the G into an E and a B. So E plus B, and that's AB. Bear with me. Hopefully this is sounding confusing. Equally, let's say you're doing G plus E and you think I'm going to make an AO. So then I guess you need to know that G plus C is AO. So you've got to split the E down into a C and a B. So G plus C is AO plus B is AB. This is what we want children to be able to do, to develop fluency. You can see how challenging that is. And if they're going to be able to reason at that level, they're going to have to be so secure within small quantities to be able to do that. So their understanding of how E is broken down or how 5 is broken down is so embedded in their long-term memory that it doesn't take up a lot of working memory space when we develop to getting to that point. Again, I would imagine there you'd be looking and you knew it was 15 there. And how would you know it was 15? Well, you probably just moved 1 from the 6 to make the 10, and that left 5, sorry. So there, I guess what we're saying is I just need to move an A to add to the I to make an AO. And so then I take I'm going to have a look, I take the F and I take A off, so that leaves me with E. So it must be AE. You can see the challenges that we're facing. And again, if you had to go at that count sequence, how much more difficult count sequences go when we have to repeat B, D, F, H when we're adding a tens value as well, A, B, A, D, A, F, A, H, B, O, B, 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 D, and so on. The challenges children face in early maths. How can we help them and break these key milestones down into small enough steps? That's been a great passion of mine. I'm still enjoying trialing that out in the classroom, and I hope to share some really useful ideas of what I've trialed and discovered and what I've learned in the last few years in doing so. Now, the first thing, this was a suggestion that I remember first getting from Mike Askew, which was about helping children to count on. I'll refer to where you can find this document on my website later, but But Mike was talking about the importance of children being able to count on, and this as a game is a really important vehicle for them to get there. And playing this game, research has shown 5 times for 10 minutes makes a really big difference in attainment for children, specifically where they're finding it difficult to count on. Now, we looked at the challenge of being able to count on in that example just before. The important thing when we're playing this 2-player game, you each have a counter, and it's whoever gets to 10 first is the winner. But you get a 1 or a 2 on your go. So it's really important that it's only a 1 or a 2. We can't play this game with a dice. So an adapted coin or a spinner or a dice with a 1 and 2 on each face would be useful. I remember playing this game with a child who was on 6. And if he was on 6 and he got a 1, he would move his counter. Now, the important thing is you just move it and say 1, or say 1, 2 if he gets a 2. He must say the next number, so 7 or 7, 8. Now, when he got a 1, he would say 7 and move from 6 to 7. But if he was on 6 and he would get a 2, he would say 6, 7, and then realise, I've only moved 1 space. And it was visually very apparent that, which you may not have noticed otherwise. And so such an important game for learning to count on, say, from the next number in the count, but not cognitively being overloaded in doing that, because I'm only getting a 1 or a 2. So I can track those sounds, 7, 8, as being 2 sounds. Now, if we go back to the number system, the thing that I wanted to really emphasize again was this importance of children having security in small quantities and them being able to represent quantities in different ways. Now, to provide guidance on how to do that and how to break thinking down into small enough pieces, with the schools that I've supported and with training, I've used what I call my Number Foundations assessment. Now, this document, you won't be able to read it from here, I shouldn't imagine, but it will be made digitally available to you. And it breaks down key skills in early number sense, in counting, counting and quantity, so strengthening our understanding of quantity through counting experiences, and then quantity recognition, so children's ability just to immediately recognize quantity. And these ideas, I believe, are well researched in terms of having a significant impact on children's long-term success in maths if they can build these skills. And hopefully it really breaks down into very small, clear pieces the key number sense skills we want to build for children. I'm going to go through it a step at a time. So we're going to start by looking at counting, and then we're going to move on to counting and quantity, and then we'll move on to looking in this session at quantity recognition. Now, I wanted to start briefly here, and this section more looks around the mechanics of children being able to count and breaking down where children are having difficulties in counting, for us to deconstruct, well, what exactly is it that difficulty stems from? Which counting skills do we have, and which counting skills are we looking to develop? And how do we expose children, for example, to the forwards and backwards number sequences so they can hear those number sounds in a range that's appropriate for them within their everyday experience? And then as children developing one-to-one correspondence, how is it that we adapt counting experiences, if that's the focus, suitably for that skill? So whether that's counting physically larger objects, which will kind of help us to separate sounds and have exaggerated physical movements, or even within counting to represent one-to-one correspondence with exaggerated physical movement as well. Now, if the skill we're developing within counting is tracking which objects have been counted and which haven't been counted, then I might use different arrangements in looking at counting. So I might move away from linear arrangements using physical objects to then maybe children counting objects that can't be moved, say on a picture, or non-physical objects like claps and jumps. But then we get to this really important point where children need to know that the final number in a count is the quantity for a set. So children might be able to count items and say there are 1, 2, 3, 4, 5. And then if we ask, so how many are there? We have to go from an ordinal process of saying 1, 2, 3, 4, 5 numbers in order to a cardinal process, and knowing that now what I'm describing is the quantity for the set. Now, subitizing, which we'll come to, really helps inform counting in that way, because that's more about cardinality, whereas counting is more of an ordinal process. But really important that children get to combine those ideas. Now, one thing I wanted to come to is this idea of drawing out a lot of these skills in children's play experiences. So rather than, as an example, one thing that I perhaps have previously done is shown children how to count and giving them context to counting that aren't particularly engaging for them. But if I had an example and I've put some cubes in my hand and I was to say, I'm going to show you here, this is as many as I can hold. How many do you think there are there? And now children have this idea of trying to get a feel for quantity. And that's the purpose of this counting, to answer this problem, this question of how many, and then maybe we could have another look. So children will tie together then an estimate, and then I have a kind of purpose for counting. Now I could then count out and model the counting process of counting how many I have in my hand, and as it happens, it is 10. And then I could say to children, well, I'm just going to leave some of these counters out. I wonder how many you'll be able to hold. Do you think it will be more or less than 10? And we could talk about, compare the sizes of our hands, say. But always trying to think, how is it that we can really deepen children's experiences and get into their natural way, curiosity and play. And also we know that corresponding to long-term success in maths more is if we can count a quantity out from a larger set, because then of course I'm not defining where the count needs to end. Now, an aspect though of the number foundations assessment, which I think I hope you'll find really useful, is what I call counting and quantity. So if counting can be a mechanical process, we need to ensure that it deepens children's understanding of quantity through their counting experiences. Now, first of all, do children know when it's appropriate to count, when they need to compare quantities? So we can choose to count if we're looking at a comparison. If I'm looking at which group is larger or smaller, sometimes I will and won't need to count, and children actually recognizing that there are times when I do need to count to do that. And now to deepen that skill, what I would consider is giving children what I would call counterintuitive perceptual clues. So let's say if I was to hold this up, the perceptual clue is that there are more yellow, because the yellow counters cover a wider space than the red ones. But for children, again, to then develop that initial skill of choosing when to count to compare similar quantities with counterintuitive perceptual clues. And again, I could do that with larger and smaller objects. Now, of course, key is children know that quantity is unchanged. If objects are rearranged and moved, they don't have to recount them. But what I wanted to move on to now is something that I found really interesting, is how can we then deepen the challenge within counting? A few things around counting experiences, and this I find interesting. So let's say I was to go 1, 2, 3, 3, 4, 5. Now, often children will be able to say that was incorrect. You did that incorrectly. That was wrong. But they may still think there's 5 in here, because they need to know that because the count was wrong, that means that the final number is no longer the quantity for the set. Now, if I was deepening there and I went 1, 2, 3, 3, 4, 5, you might know that there was one error in that count. So the quantity in here, not only is it not 5, but it must be 6. Now, a few other ways that I could vary that kind of challenge. And I'm counting into the pot here, so children can't just subitize how many, see how many and say. Let's say I was to say 4, 3, 2, 1. How many here? Now, the final number in that count doesn't represent the quantity for the set. It's the first number that does. So if we do that again, 4, 3, 2, 1. How many in the pot? And of course, there it's in this case it's 4, the first number in the count. Or even if I was to 2, 3, 4, 5. How many in here now? And recognizing that the final number in the count was 5, but I started from 2. Linked to that, can children, when they count their fingers, they could count them 1, 2, 3, 4, 5. But couldn't they count them 1, 2, 3, 4, 5, and recognize that that's the same quantity? let me show you one final example around counting, and then invite you to kind of pause the video and think about how can you incorporate a lot of these ideas in your setting. And I wanted to show you a piece of research that I found fascinating. So a group of 3, 4, and 5-year-old children were asked to share a quantity in a way that was fair. So like 8 objects. So 1 for me, 1 for you, 1 for me, 1 for you, 1 for me, 1 for you, 1 for me, and 1 for you. And they're then asked, how many do you have? And they say, I've got 4. Now, all the children that could do those 2 things correctly could share fairly and could say how many they had. These are 3, 4, and 5-year-old children. They're then asked, so how many does the other person have? And only 1/3 of those children actually knew that the other person must also have 4. And the other 2/3 needed to count to check how many the other person had. But these skills of actually understanding and being able to reason and understanding quantity through counting are so powerful and so predictive of children's long-term mathematical success as well. So before we look at recognizing quantity, let me just invite you there to pause the video and have a think. How could you apply any of these principles in your setting, or what's really stood out for you so far? Then the next part of the number foundations assessment is children's ability just to recognize quantities, immediately recognize quantities in these specific arrangements. Now, first of all, we want children just to immediately be able to recognize 1, 2, or 3 in any arrangement. And we know that if, for example, children can't immediately recognize 3 and know it's 3, improving their ability to do that, tying their counting to their ability just to recognize 3 and then just immediately recognizing 3. So maybe taking away the option of counting, so flashing some 3 up and taking them away, improves their long-term success in maths. And a way of recognizing 1 is one hand, 2 is in both hands, and 3 is 1 more than both hands. But really important that we can just immediately recognize up to 3. When we come to subitize larger quantities, just immediately know how many. If we're looking at, for example, 4, then it's likely that we'll then have to conceptually subitize. So put parts together, maybe see a 3 and a 1. We won't necessarily be able to look at 4 and know it's 4. And very rarely would we be able to look at 5 and just in one clump know that's 5. So we need children to have this ability just to immediately recognize up to 5, but recognizing that becomes much harder when we go beyond 3. So a game that I sometimes play is just blue tacking counters on a whiteboard, turning it around, showing children, turning it around and say, I want you to make what you saw. So children are able to have to represent that pattern and talk about the parts that they see. When we come to recognize larger quantities, we'll generally want to do that around a base, normal representations that children can then subitize, like dice patterns or base 5, base 10 visuals. And I guess what I mean by that, the 2 really, is 10 frames and your fingers. So being able to represent 7 using a 5s and how many more structure, as well as in other ways. Again, I need to look at my fingers to be able to do that. I'll look at some research when I go to the website around finger discrimination, which I think is fascinating. And actually my ability to use my fingers is really important. And part of that is actually just my ability to discern between each finger. So again, we'll come to that and we'll have a look at that. Now, when children are immediately able to recognize quantities, for example, if I just flick on in 10 frames, we want children to know in those 10 frames, for example, that the orange counters, that there are 8. And they will first of all need to know, well, they'll need to know it's 8 because there's 5 and 3. And first of all, they'll need to know that row is 5. So we might start representing in a 5 frame and seeing that 5s and how many structures, or learning to count in groups of 5s and how many more. And then when we're seeing, we want to be able to see 5 plus 3, that's why it's 8, or maybe it's 2 less than 10. So numbers and their relation between 5 and 10 being really crucial. And of course, 10 frames great for doing that. And for physically doing that with 10 frames is different sizes in different ways. And then just being able to look at images and then dots positioned in different ways on 10 frames and being able to say immediately how many being really key. And again, I'm going to show you lots of resources, including the dot patterns cards, but we want the children, for example, on the image on the left-hand side to be able to say, immediately be able to say, it's 5, and no, because there's parts there of 3 and 2. Now, these are all obviously the kind of mechanical skills, and the thing that's so important is finding ways that how in children's kind of moment-to-moment experiences, especially in contexts that have personal significance to the children, do we get them practicing and seeing these skills in, as I say, this wide variety of situations, and just being able to be really fluent in recognizing those quantities in different ways. Again, I'm going to come and show you lots of games and things that can be done to help to achieve that. Now, once we're able to represent and recognize quantities, I would say before we come to break down quantities in different ways, or maybe alongside, we need to help children to become fluent in the idea of parts within a whole and subgroups. So the idea that, let's say in a family, so this might be an example with personal significance, there are 5 people in the family, and there are maybe 3 children and 2 adults, or maybe there's 4 girls and 1 boy in a family. But finding situations with personal significance to children and showcasing them as being really key. Let's say, for example, the idea that in a class, there are more people than children. Now, it's possible to think that children is more because it's a very large subgroup, but us to get the idea that that in this context, that's a subgroup. So it might be that in a picture, poppies is a subgroup of flowers, and lots of context and language around that as being really important, being able to discern between parts and wholes, particularly in examples that have significance for children. Then I would look at using the same representations, if I flick on again, but using 2 color visuals to then break down and see number bonds. So for example, I've got dice pattern cards, the middle example in 2 colors, in a red and a blue. I had to really think about that then. And so for children to be able to say the whole is 6, the parts are 4 and 2. Or one of my favorite, which is butter beans. So on the left-hand image there, we're rolling 5 onto a paper plate. So we've got a butter beans spray painted gold on one side, and children roll them and they're able to say how many beans and how many magic beans. So the magic beans have been invaluable. Then I've got a range of different games like Make 7, I'll show you that in a moment, for helping children to see parts and wholes. So if you just let me flick again to the screen here. So one is, let's say one thing, we want the children to be able to immediately know that's 4 and that's 2. And I often put a range of these kind of cards out and say to children, like we're playing 6 sandwiches. So with a range of different cards, they might find the 4 and think, I need to find a 2, and then they find a 2. And so there I've made a 6 sandwich. And then we could use this and hold it up. And if I show a child this, they've got to say 2. And then we look at the other side and yes, it is a 2. And so we've got a range of different 6 sandwiches. So these are the whole cards as well in 10 frames with the 2 color visuals. Now, of course, we can do this practically with counters and turn the counters over. But we want, of course, the children to be able to say the whole is 10, the parts are 4 and 6, and have these consistent images that they see to be able to break these numbers down and play with them and do them in different ways. So building on children's practical experiences, and then eventually them needing to build this into abstract thought. So it's not something they need to do practically to find the solution, but it's got to become, as I say, abstract mental model. Now, a few little games that I often use to help children with this. One is Make 6. So there is a Make 6, Make 7, Make 8, Make 9, Make 10. And so the idea with Make 6, so I haven't got my dice with me. That was a faux pas. But let's say I roll a 4, then I'll just colour in 4, and then 2. And I can see that 6 has got parts of 4 and 2. Or another one, when I'm kind of looking more formally at introducing number facts, this is another little game that's on the website as well. And the piece at the top, the picture at the top, is actually the same size as a Numicon piece. So excuse me. So the children can access this, if they're unsure, by positioning the 5 on, and they can see it's parts of 5 and 1 that equal 6. So lots of little games and lots of ways of showing children these parts and wholes. So let me have a little look at my website and some of the resources that are on there. So it's icmaths.com, free resources, early number sense, and everything on here is totally free, no login required or anything like that. And share and have a look at some of the resources and think how they can be used by yourselves. And then I'd invite you to think, how could you use the Number Foundation's assessment, kind of assess the children's capacity to understand those kind of key ideas, how we represent concepts, and again, give you some time to have a look at some of the resources here. So again, I'm going to do a bit of a look. So we've got dot patterns cards 1 to 3 and 4 to 6. Some of the 1 to 3 cards are different sizes because we know that adds children's understanding and their number sense there. So there, for example, the dot pattern cards in the range 4 to 6. There are also some subitizing games. So what you do for a subitizing game, if we just click on one, how many dots, that brings up a pre-made game. So you'll be able to open that game up and play that one, and they're very easy to edit and amend. So we'll have a little go of this one. So these are literally games that you could play in 2 or 3 minutes. So we flash up some dots, take them away, and the children say how many dots. They could whisper to the partner how many dots they saw. So there's the first one. You maybe say how many you saw, and then the next. And then we could talk about how they're broken down and so on, and the next. And then the last one. And then all the images appear at the end. So there's various games, subitizing games that you can use or you can amend. And we can look at that last screen to talk about how many we saw, what the parts are that we saw, and so on and so forth. So that one, of course, is representing quantities in 2 different colours. We have one above with different sizes, and then just kind of regular dot pattern games. Lots of other little games to explore, like Domino's Car Park for parking dominoes in different grids. Match Bingo, where children roll a 1 to 6 dice. So I generally print these ones off, so I could print like 4 of these grids off per A4 page. And then Match Bingo, we roll a dice, and if we roll a 5, we've got to cross off a representation for a 5. So lots of other things there. So there's subitizing games and cards for 10 frame cards 6 to 10. And if I just point out with these ones, it's the idea that we want children to be able to recognize how many dots, and in doing so we're kind of almost building different skills with the dots arranged in different positions. You might hear my girls singing in the background. We've got finger cards there, how many lines cards similarly, and then I showed you the part whole cards. So for example, the 10 frame cards in 2 colours are there. They can be cut out and used and so on and so forth. The Make 6 games, the Bonds to 6, 7, 8, 9 games are all there. There are doubles cards which we'll come to. Count on races, I talked about before. That is, there are 3 grids there, race to 10, to 15 and to 20. And then let me just show you another thing which I think is really great. There's 1 or 2 other bits there you might feel free to peruse. In fact, 2 other things. The first one quickly is the teens and tens cards. So love these for helping children to discern between teens and tens numbers. So cutting the cards out and they have to match 13, 31, 14, 41 and so on. And of course the colouring helping to show the structure of 14 as the 4 in the word 14 being represented by the 4 ones and the teen being represented by a 10. So a big fan of the teens and tens cards. Now, I found that this article about finger discrimination is fascinating, and this one is a similar message. It talks about the importance of children being able to use different fingers, so feel free to have a look at that. And then also the finger discrimination tasks. These are by a company called U-Cubed for developing children's finger dexterity. So, for example, the maze task, where children have to follow a different maze with a different finger. So they have to be able to use different fingers, and that corresponds very powerfully to children's actual arithmetic skill. So lots for you to pause and have a look at there. Can these resources be useful? How about this principle of number sense? How can that further be built? And we'll come back in a moment. When you've paused the video, we'll come back to have a look at deepening in pattern. And let me just say now, the guidance around pattern is also at the bottom here, and we'll come back when you restart the video looking at that element. Again, there is guidance around this at the bottom of the early number sense page, but one thing that I'm fascinated about as well is developing children's understanding of pattern, and the foundations for that, and how to develop that through Key Stage 1 as well, because again, we know that children's understanding of pattern is very predictive of the long-term success in maths. It's a brilliant vehicle for getting children reasoning, and again, it is a really, really important building block, and it's something that I've learned a lot about recently, how that understanding can build. The starting point would be children being able to first of all make what we call an A-B pattern. So say for example, if we're looking at that middle top picture, being able to make represent the blue and the black, that pattern, just by building the same thing. is starting point number one, like the picture of the girl at the top. So the first thing is I can just make that pattern. Then we get to this really important second step of I can represent that AB pattern in a different way. So we have a look at this middle set of pictures. We've got either a drawing of the orange and the green, and that represents this pattern, or we can make that pattern with something other than the actual cubes. So we have this abstraction of that this yellow piece of paper and the orange piece of paper represents this pattern. And then I'd want to do the same thing for an AB pattern. Build it and then represent it. Now, once I've done that, I would look at being able to then extend that AB pattern. So be able to just add more on. So rather than copying a pattern, now I'm recreating a pattern. Can we spot mistakes in repeating patterns? And then when children can see an AB pattern, then what we've asked them to do is break it up into pieces. And we want children to see what's being repeated, the A and the B. Now, from there, we're ready to explore different kinds of patterns. And of course, we'd be looking at patterns in all kinds of contexts using non-physical objects, so claps and jumps, or inside and outside, and lots of different forms of pattern. But, excuse me, a while ago, the NCETM released some research around pattern that I thought was fascinating. And it was saying to outwork these ideas with different kinds of patterns, like ABB patterns, and in this case, an ABC pattern. First of all, continue patterns, make and continue patterns. Then try and spot mistakes in patterns. So I might show children a pattern, ask them to close their eyes, and then put a mistake in. Rearrange the items, take one out, add one in. Can they find the mistake? Much more challenging. Can they correct the mistake? Then, and again, I think this is fascinating, giving children, for example, sticks, stones, shells, pine cones. So more items than there are in this pattern, and saying, I want you to make this pattern. And we want the children to see that the underlying structure is the same. If I have shell, stone, pine cone, that is this pattern. I don't actually need these objects to make that pattern. So I generalize about the pattern. And then I want to be able to identify the unit of repeat. So describe this pattern. So tell me about this pattern. We want to get to the point where it is, I have to look carefully now, green, red, yellow is the pattern. I don't just say everything in the pattern. Now, to add challenge from there, well, I can take that pattern, put it in a circle. So now I'm not defining a start and an end point. And of course, the challenge, I could look at all those things in that same structure. So then can you extend that pattern? How do you extend that pattern? What's the unit of repeat? And it really deepens children's thinking around that. Now, taking that even further, I could then give children a fixed number of spaces and ask them to create a circular pattern. And the challenge there varies depending on how many spots how many spaces, I should say, in the pattern. So this is an example of a 12 space pattern, a relatively easier one to do, but where children have to start thinking, well, which kind of pattern will mean that I've got a circular continuing pattern. It's a wonderful way within pattern of really deepening children's thinking and drawing out even multiplicative thinking. So again, I just invite you there to pause the video and have a think about have a look at that guidance and have a think about how you can deepen children's thinking within pattern, how we first structure that learning and then where we can go. So again, pause the video and have some discussion around. So I think it's really important to give children real significant challenges, but within a small number range. So what I wanted to do now is just share 2 examples of some of my favourite tasks that I've used with children in year 1, so that we're just calculating within 10, but the significant challenge in reasoning and problem solving, open tasks. So let's go and have a look at them. The example on the left, we've got to find different answers, and the answer has got to be in the 5 times table. So the children have to be able to reason that the answer has to be either 10 or 15, it can't be 20. And then think about all the different combinations that it then could be. Now, the example on my right is a bit of a favourite, and what I'm going to do, I've always loved this one. I'm going to go switch the screen and show how this one can be outworked. So the children have to basically complete the cherry model, and let's say they come up with an example. So we go for an 8 at the top, and let's see if we can do it with a 5 there and a 4 there. Is that possible? And then that will leave us with a 2, and if I have a 3, yeah, there we go. So there, I've accessed that by finding an answer. And now we could say, I wonder if you could do it with a different number at the top. Is that possible? And then again, children could maybe find a way where they have, let's say they've got a 9 at the top, and then maybe we have a 7 and a 2 and so on. You know, they could find a different way. Is that one? Yes, it is, if there's a 6 there. Now, the way that I like to add the challenge here is say, well, what's the small, I've seen you do that with an 8 and a 9, but what's the smallest number that can go in that top circle? How do you know that's the smallest number? And children exploring what it could be. And actually, it is a good one because it can be 7, it can be 6, and then the children often get to the point, well, it can't be 5, and they basically try the different ways. So 3 and 2, but then you can't make the 3 because you can't use the 0 because then I need another 3, which I don't have. I've used the 2 and the 1, but what we want the children eventually, or where we can get to eventually, is looking at, well, 6, I can actually make, and I know that I make it in this way. And what I want to draw out is the fact that, and if I move these digits out of the way, that actually this number is the I get by adding these 3 numbers, and so therefore this must be as small as it can be because I've used my smallest digits that I can use. I can't use the 0, but it is 1, 2, and 3, and therefore it couldn't be any smaller than that. So again, great for, I've had year 1 children accessing this idea, but getting to that level of reasoning, you can see how the kind of depth can come in there. Now, the last little feature I wanted to have on this video was around estimation. And let me also point you towards this wonderful website and organisation, the Ericsson Institute of Early Maths Collaborative. So lots of ideas and information on here. So this could be something to go away and explore afterwards. So if you have a look, why early maths and the big ideas of early math, then we have, and note the American accent there as well. We've got some of these key ideas that predict long-term success in maths for children, and information there for you to explore. So again, that is the Ericsson Institute. Now, the Ericsson Institute produced lots of useful little videos, and I wanted to show a couple of them to stimulate some thought around estimation, and hopefully tying together a lot of the themes that we've looked at already around subitizing and counting and number sense and developing this real feel for quantity. So I'm going to hand over now to the Ericsson Institute, and let's have a look at these 2 examples.
Can you tell me how many of these are?
3.
That's 3. I'm going to put some more in here, and I don't want you to count, but you know that's what 3 looks like. I want you just to estimate how many of these are. How many is that? It's just 3. How many do you think that is?
I think it's 6.
Can you say that again? I think it's
6.
I think it's 6. Okay, so if that's 6, then I want you to make a guess about how many are here.
That's
If this is 6, how many do you think that is?
These are a bunch right
Can you
here.
say that again? Look at me.
These are a bunch right here.
There's a bunch. Can you give a number to that bunch? Is it more than 10?
1,000.
You think maybe 1,000? That's more than 10?
Yes.
And there we can see 1,000. That's a big number. It's a big amount. It's a big number. But I love there the adult and the use of the adults benchmark measures in showing. So if this is 6, how many here and how many 6s in? And let's have a look at another similar video.
If that's 7, then how many do you think all of this is? 1,000? Think it's as many as 1,000? You sure it's that many?
Yeah.
Not maybe 100?
100.
Think maybe 100? You're not.
Yeah.
You're not sure. It's a lot. It's
Yeah.
more than the 7.
Yeah.
It's a lot of 7s.
No.
How many 7s do you think are in there? How many of these do you think fit in there? Think maybe 3 of those fit in there?
Yeah.
So if we had 7 and 7 and 7, how many do you think that would be?
8.
Perfect logic there. But what I hope that would encourage you to think about is how we could use benchmark measures within estimation and how we could draw out a lot of that language as well, so that estimation is a skill where children have got something to really hold on to, and seeing different, as I say, different benchmarks amounts, because that we know where children estimate and then use counting to check an estimate or have that as this number sense feel, that again will build this understanding of quantity. which is so important as children go on in their maths journey.